Welcome to the Explainer. Today, we are diving into some really fascinating new research that shows how quantum computers are taking on a billion-dollar problem in the world of finance: how to predict major credit downgrades. So let's start right at the heart of the problem. This isn't just some abstract financial term. It's a very real risk that, frankly, keeps bankers up at night. So, in this first section, let's really unpack why predicting these events is so incredibly important and why it's so darn difficult. Okay, so what exactly is a fallen angel? Well, imagine a borrower, could be a big company that was once considered a really safe bet, investment grade. But then its financial health starts to slip, and suddenly it gets pushed down into a much higher risk category. For the banks, the whole game is about seeing this coming before it becomes official. You see, crossing that line from investment grade to sub investment grade isn't just a simple label change. Oh no. It can set off major financial shockwaves. It can force entire institutions to sell off bonds. And all of a sudden, it becomes way more expensive for that company to borrow any money. It's a big deal. To try and predict this shift, banks, of course, pull out their most powerful tools. And right now, the gold standard is a machine learning model called a random forest. It's a super complex approach that basically just throws a massive amount of computational power at the problem. But here's the catch, and it's a big one. To make just a single prediction, the standard random forest model they use for this combined the outputs of 1,200 individual decision trees. Yeah, 1,200. It's kind of like having a committee of 1,200 experts all shouting and trying to vote on the right answer at the same time. And all that massive complexity, it creates some pretty serious challenges. For one, training this model takes over 3 hours. Two, it's basically a black box because no human can really understand how it's making its decisions. And three, it just relies on a simple majority vote, which, let's be honest, isn't always the smartest way to combine different insights. So clearly, there is a lot of room for improvement here, right? We need a model that's faster, more transparent, and hopefully just as accurate. And this is exactly where the research proposes a quantum solution. The core idea they had is just a fundamental shift in strategy. Instead of relying on the brute force of that huge, dense forest, what if you could intelligently pick a small, elite team of predictors and then find the absolute optimal way to weigh each of their individual opinions? The solution they came up with is a hybrid approach, which is really clever. First, your normal classical computers train a whole bunch of simple models. But then, and this is the key part, a quantum computer takes over to tackle the exponentially difficult job of finding the one single best way to combine all of them. So, what kind of hardware can actually make this possible? Let's take a look at the computer itself. Because now we're moving from the theory of the algorithm to the actual physics of the machine that runs it. The heavy lifting, the quantum part, is done on something called a neutral atom quantum processor. It's amazing. In this machine, individual atoms are held in place by what are essentially laser tweezers, and their energy states are used as qubits, the basic building blocks of quantum information. It is quite literally computing with atoms. So, the moment of truth. How did this hybrid quantum workflow actually perform? The researchers tested it on 20 years of real financial data and put it head to head against the classical champion, the random forest. And the very first result is this dramatic difference in complexity. The quantum optimized model needed only 50 predictors, compared to the 1,200 used by the random forest. I mean, that is a huge leap in interpretability. It creates a model that a human can actually look at, analyze, and most importantly, trust. Now, looking at the head to head stats, the results get even more impressive. The quantum classifier achieved pretty much the exact same precision, 27.9% versus 28%, while using that tiny fraction of learners, and it cut the training time from over 3 hours down to about 50 minutes. So the main takeaway here is pretty clear. Even with today's early stage quantum hardware, this method is already matching the accuracy of the classic model while being just vastly superior in efficiency and transparency, two things that are absolutely critical in the real world of finance. But yeah, the story of them there. The most exciting part of this research isn't just about what quantum computers can do today, but the really clear path it lays out for the future, using something called tensor network simulations, which is just a powerful way to kind of peek into the future of quantum systems. The researchers project that as the hardware gets better, this quantum approach will just match the classical benchmark. It's going to definitively surpass it, potentially reaching 29% precision or even higher.